Hey there guys, and welcome to the 2019 Edexcel AS Level Maths Paper 1. Number 1. The line L1 as equation 2x add 4y minus 3 is 0, L2 y is mx add 7. Given that the lines are perpendicular, find the value of m. So, if lines are perpendicular, their gradients multiply together to minus 1. So, find the gradient of L1, and then we can get the gradient of L2. So, we need to get L1 in the form y equals mx add c. So, we're going to add 3 and subtract 2x. And then divide by 4, we get y is 3/4 minus 1/2 x. Now, what multiplies minus 1/2 to give us minus 1? It's positive 2. So, m is 2. Given part B, the lines meet at point B. Find the x-coordinate of B. Okay, so where they meet, they are equal. So, we can say that 3/4 minus 1/2 x is equal to 2x add 7. Okay, now I would multiply through by 4, so we get 3 minus 2x is 8x add 28. So then we can get minus 25 is 10x, so x is minus 2.5. Number 2. Find, using algebra, all real solutions to part 1, 16a squared equals 2 root a. Alright. Divide through by 2. First of all, we get 8a squared is root a. Square both sides, we get 64a to the power 4 is equal to a. Divide through by a, we get 64a cubed equals 1. Divide by 64, we get a cubed is 1 over 64. Cube root, and we get a is 1/4. Part 2, b to the power 4 add 7b squared minus 18 is equal to 0. So this is quadratic, although it might look a bit scary. So what we can do, if you want to, you don't have to, you could say let y equal b squared. Then that means b to the power 4 is y squared. So then we have y squared add 7y minus 18 equals 0. Which factorizes to y minus 9, no, sorry, y plus 9 times y minus 2 so y is then minus 9 or 2. Now remember, y is b squared, so b squared can equal minus 9. Now that we can't square root, so there are no real solutions. Or b squared is 2. So b can be positive or negative root 2. Given that k is a constant, find the integral of 4 over x cubed add kx dx, simplifying your answer. Alright, so first up, I would write the fraction in power form. So this is the integral of 4x to the minus 3 add kx. Okay, so x to the minus 3 goes up to x to the minus 2 and we divide by the new power. So 4 divided by minus 2 is going to give us minus 2x to the minus 2. Now kx is going to integrate to kx squared over 2. Now it's indefinite, so we need plus c. Now we can't leave it like that, or we could write it as minus 2 over x squared add kx squared over 2 add c. Part B. Hence, find the value of k such that the integral between 0.5 and 2 equals 8. Okay, so the integral is now defined, so we can forget the plus c. So all we now know is our integral between the limits is equal to 8. So we're going to plonk in the limits. So 2 goes in first. So minus 2 over 4 is minus a half. K times 2 squared over 2 is 2k. And then we subtract what we get when we put in 0.5. So minus 2 over a half squared is minus 8. And then we got k times a half squared is k over 4. That's divided by 2, so that's k over 8. Okay, so we have minus a half minus 8, so that's 7.5, so that's 15 halves. Now then 2k minus k over 8 is 15 eighths k. And that's equal to 8. If we then multiply through by 8, we get 60. Add 15k is 64. Take away the 60, divide by 15, we get k is 4/15. Okay, number 4. A tree was planted in the ground. Its height, 8 meters, was recorded 2 years after planting. Exactly 3 years after planting, its height was 2.35 meters. Exactly 6 years after planting, its height was 3.28 meters. Using a linear model, part A, find an equation linking h with t. Okay, so if it's linear, we know it's going to be of the form h is equal to mt add c. So m is the gradient, that's going to be the difference in height over the difference in time. So m is going to be 3.28 minus 2.35 over 6 take 3. Now that gives us 0.31. Okay, so we now know h is 0.31 t. Let's try that again. 0.31 t. Add c. Now we use one of the points to find c. So I'm going to use t is 3, h is 2.35. So I get 2.35 is 0.93 add c. Now that then gives me c is 1.42. So our model is then h is 0.31 t. Add 1.42. Given part B, the height of the tree was approximately 140 centimeters when it was planted, so 1.4 meters. Explain whether this fact that this fact supports the use of the linear model from part A. So, using our model, when t is 0, we get 1.42 meters. Now, 1.42 meters is very close to 1.4 meters. So you would want to say that, and then also say, because of that, this does support the use of the model. 5. A curve as equation y is 3x squared add 24 over x add 2. Part A. Find in its simplest form dy by dx. Okay, so write it in power form first. So y is 3x squared add 24x to the minus 1 add 2. Okay, so dy by dx is 6x minus 24x to the minus 2. So minus 24 over x squared. And the plus 2 disappears. Okay, then for part B, we want to find the exact range of values of x for which the curve is increasing. So, for a curve to be increasing, this means that dy by dx gradient is positive, so greater than 0. So, that means then that 6x minus 24 over x squared is greater than 0. Now we can multiply through by x squared, and I'm also going to add 24. And then we're going to get 6x cubed is greater than 24. Divide through by 6 and cube root, we get x is greater than the cube root of 4. Okay then, number 6a. Given that the area of this triangle is 18 root 3, we want to show that x is 2 root 3. Okay, so we're using trigonometry area of a triangle. So the area is 1/2 so 1/2 times the two sides coming out of the angle, so times 2x times 3x, so that's 6x squared, times sine of the angle, so sine 60. So that's going to give us 3x squared times root 3 over 2. Now, we also know the area is 18 root 3. So, from that, we can now say then 3x squared over 2 is 18. Multiply by 2, divide by 3, we get x squared is 12. X is then root 12, which is indeed 2 root 3. Given part B, and find the exact length of BC, giving your answer in simplified form. So we now have a triangle where we know 2 lengths and an angle, and we want to find a third length. So we can now use the cosine rule. So I've put the 2 lengths on that we now know. So using the cosine rule, we are going to get a squared is equal to 4 root 3 squared, which is 16 times 3, so that's 48. Add 6 root 3 squared, which is 36 times 3, which is 108. Minus 2 times 4 root 3 times 6 root 3 cos 60. So, minus 2 times 4 root 3 times 6 root 3 cos 60. So, a squared is 156 minus, now cos 60 is a half, so 2 and that cancel, so we're just doing 4 root 3 times 6 root 3, which is 24 times 3, so 72. So, a squared is 84. So, A is root 84. Which is root 4 root 21. So, 2 root 21. Given number 7, the curve C has equation y is k squared over x add 1, where x is in the reals not equal to 0 and k is a constant. Part A enters the sketch C, stating the equation of the horizontal asymptote. So, this is just a transformation of 1 over x. Now the k squared doesn't do much. Now 1 over x roughly looks like that. So it never touches the axis. Now the plus 1 moves the graph up by 1 unit. So your sketch wants to look something like this. So the horizontal asymptote is now at y equals 1. And part B, the line L has equation y is minus 2x add 5. Show that the x-coordinates of any point of intersection of L and C are given by solutions to 2x squared minus 4x add k squared is equal to 0. So, at intersection points, we know k squared over x add 1 is equal to minus 2x add 5. Multiply through by x, we get k squared add x is minus 2x squared add 5x shift everything over to the left, 2x squared minus 4x add k squared does indeed equal 0. Part C, hence find the exact values of k such that L is a tangent to C. So a tangent hits curve exactly once. So that means that we want this equation to have just one solution. So, it's quadratic, we need to think about the discriminant. So, for exactly one solution, the discriminant b squared minus 4ac equals 0. So, we have our a, b and c. So b squared is 16. Now minus 4ac is going to be minus 8k squared. So from that we can get k squared is 2. Square root k is plus or minus root 2. Okay, number 8. Find the first three terms in ascending powers of x in the binomial expansion of 2 add 3x over 4 to the power 6, simplifying the terms. Okay, so we're going to have first term we have 6 choose 0 times 2 to the power 6 times 3x over 4 to the power 0. Then the next is 6 choose 1 times 2 to the power 5 times 3/4 x to the power 1. And then the third is 6 choose 2 times 2 to the power 4 times 3/4 x squared. Okay, so first term is nice. That's just 2 to the power 6, which is 64. Second term, 6 choose 1 is 6. So we got 6 times 32, which is 192, times 3x over 4. And then the third one, 6 choose 2 is 15. So we have 15 times 16, which is 240. Now that is multiplying 9x squared over 16. So we can simplify that a tiny bit more. We should get 64. Add 144x. Add 135x squared. Part B then wants to know how we would use our expansion to estimate the value of 1.925 to the power 6. So, what we're doing then is thinking of to add 3/4 x as 1.925. You would then solve this for x. Now if you want to do it, you should get x is minus 0.1. And then substitute that value into our expansion. Number 9. A company started mining tin in Riverdale on the 1st of January 2019. Our model to find the total mass of tin mined is T equals 1200 minus 3 lots n minus 20 squared, where T tons is the total mass of tin mined in the n years since the start of mining. So, using the model, calculate the total mass of tin mined up to the 1st of January 2020. So n is 1. So all that we're doing is calculating T of 1. So that's 1200 minus 3 times 19 squared. And that will give us 117 tons. B. deduce the maximum total mass of tin that could be mined. Okay, so the model is quadratic in completed square form. Whatever's inside the bracket, when we square it, is positive. So because we're subtracting that part to get the maximum, we need the bracket to equal 0. Now that's gonna happen when n is 20. So when n is 20, we get t is 1200. Given part C wants us to calculate the mass of tin mined in 2023. So that's not saying up to 2023, just in 2023. So what we're going to want here then is total on 1st January 2024 minus the total on the 1st January 2023. So we need to calculate t of 5 minus t of 4. So, for those, you should get 525, and then minus 432, and that gives us 93 tons. D. State, giving reasons for limitations on the value of n. So, the model is fine from n is 1 up to 20. As soon as n is bigger than 20, t, which is the total mass mined, is going to start decreasing again. So really the model is only valid up to and including n equals 20. So we could say the model is only valid for n less than or equal to 20, as for n greater than 20, t starts to decrease, which doesn't make sense. Okay, number 10, a circle has equation x squared add y squared minus 4x add 8y minus 8 equals 0. Part A wants the centre coordinates and the radius. So to do that, we need to write this equation in this form. So we need to complete the square twice. So x squared minus 4x is x minus 2 squared minus 4. Y squared add 8y is y add 4 squared minus 16. And then we add minus 8 equals 0. So we've then got x minus 2 squared add y add 4 squared is equal to 28. So the centre is 2 minus 4 and the radius is root 28, which we can say is 2 root 7. Okay, then the straight line with equation x equals k, where k is a constant, is a tangent to C. Find the possible values of k. So these are vertical lines, so either the tangent hits on the left side of the circle or the right side of the circle, just once. So the two possible lines are these guys. So it's either a radius to the left of 2 or a radius to the right of 2. So k can be 2 plus or minus 2 root 7. Number 11, f of x is 2x cubed minus 13x squared, add 8x, add 48. Part A, prove that x minus 4 is a factor of f of x. Okay, fact theorem. So, if x minus 4 is a factor, then f of 4 will equal 0. Okay, so let's find f of 4. So that's 2 times 4 cubed, which is 128. Minus 13 times 16, which is 208. Add 8 times 4, 32. Add 48. And that does indeed equal 0. And for part B, hence using algebra, show that f of x equals 0 has only 2 distinct real roots. So we need to factorise completely. So, because f of x is cubic, we know it can be written as a linear times quadratic. So, we know our linear is x minus 4. Now our quadratic, for now, let's just say is ax squared add bx add c. Now a we can get easily, because we know that x times ax squared has to be 2x cubed. So a is 2. We can also get c quite easily, because we know that minus 4 times c must be positive 48. So c is minus 12. So now we can say f of x is x minus 4 times 2x squared add bx minus 12. Okay, now to get b, we think about what we would get if we expand this whole thing in terms of either x squared or x times. So, I'm going to go for x times. So, if we expanded this rule out, we would get minus 4bx and we would also get minus 12x. Now, in the function, the x term is 8x. So, dividing through by x, we get minus 4b minus 12 is equal to 8. So we get minus 4b is 20, so b is minus 5. So now we know f of x is x minus 4 times 2x squared minus 5x minus 12. Okay, now the quadratic factorizes, so we can now write this as x minus 4 times, it's going to be 2x add 3 times x minus 4. Which can be written as x minus 4 squared times 2x add 3. So, finally, the roots are x equals 4 and x is minus 3 halves. And for part C, we're given part of the graph, so I've now put on what we know, so the two roots and the y-intercept at 48. Part C then wants us to deduce the number of real solutions to 2x cubed minus 13x squared add 8x add 46 is equal to 0. So all that's changed is 48 to 46. So what's happened here is the graph has moved down by 2. So it's going to look roughly like that. So it now crosses the x-axis 3 times, so there are 3 real roots. Okay, then for part D, given that k is a constant and f of x plus k passes through the origin, find the 2 possible values of k. Okay, so f of x plus k is a translation either left or right. More specifically, it's translation by minus k 0. So, looking at the graph, we either need to go 3/2 to the right, so that would be 3/2 0, or we need to go 4 to the left, so that would be minus 4 0. So, k then is either minus 3/2 or positive 4. Okay, number 12 wants us to show that 10 sine squared theta minus 7 cos theta add 2 over 3 add 2 cos theta is identical to 4 minus 5 cos theta. Okay, so we need to turn everything on the left into cos. So, we know that sine squared add cos squared is 1. So, sine squared is 1 minus cos squared. So, we can now write 10 lots of 1 minus cos squared minus 7 cos add 2 all over 3 add 2 cos. Okay, so we've got minus 10 cos squared minus 7 cos and then we got 10 add 2, so that's 12 over 3 add 2 cos. Okay, now the top hopefully is going to factorize. So, let's see, we got minus 10 cos. So, we're going to need, well, because the right hand side has no fraction, we should, on top of a factor of 3, add 2 cos. Which then means we're going to need a 4 minus 5 cos. Then on the bottom, 3 add 2 cos. For common factor of 3 add 2 cos, we do indeed get 4 minus 5 cos theta. Okay, then for part B, we are solving for x between 0 and 360 degrees, the fraction equal to 4 add 3 sin x. So, we now know the fraction is 4 minus 5 cos x. So, we're now solving 4 minus 5 cos x is equal to 4 add 3 sin x. Okay, take away 4, we get minus 5 cos x is 3 sin x. Now we know cos is never 0 when cos x is equal to sin x, so we can divide through by cos. So we get, we can also divide through by 3, so minus 5 thirds is tan x. Now, so we would get x is the inverse tan of minus 5 thirds. Now though, that gives us minus 59 degrees. Which is outside of our interval. Now, tan has a period of 180 degrees. So we just add 180 to get to the first one we want, and then 180 to get to the second. So, we get x is 121 and 301 degrees. Next up, we have part of the graph of y equals 2x cubed minus 17x squared add 40x. The curve has a minimum turning point at x equals k. The region R is bounded by the curve, the x-axis, and the line x equals k. We want to show that R has an area of 256 thirds. Okay, so we know that the area is the integral between 0 and k of y with respect to x. Now the problem is that we don't know k, so we need to find k before we can do the integral. So, finding k then. So, we know at stationary points dy by dx is equal to 0. So, we know that we should say at a stationary point dy by dx is 0. Okay, so let's find dy by dx. So 2x cubed becomes 6x squared. Minus 17x squared becomes minus 34x. And we get plus 40 at the end. So that has a common factor of 2. So if we set it equal to 0, we can divide through by 2. So we get 3x squared minus 17x plus 20 is equal to 0. Factorise that, we're going to get 3x and an x. We're going to need 3x minus 5 and x minus 4. So that then tells us x can be 5/3 or 4. So if we look at the graph, we can see the minimum is further to the right, so that means k is 4. So now we know that r is the integral between 0 and 4 of 2x cubed minus 17x squared plus 20x squared, plus 40x. So, when we integrate, we get well, we're going to get 2x to the power 4 divided by 4, so that's x to the 4 over 2 minus 17x cubed over 3 add 20x squared. Okay, so now we just need to plonk in x equals 4. So we are going to get 4 to the power 4 is 256. 256 over 2 is 128. Minus 17 times 64, 1088 over 3. Plus 20 times 16 is 320. Smash that into your calculator and you will indeed get 256 over 3. The value of a car V pounds can be modelled by v is 15,700, e to the minus 0.25t, add 2,300, where t is greater than or equal to 0 in the reals, and is the age in years of the car. Using the model part A, find the initial value of the car. So this is when t is equal to 0. So, t being 0, is, well, e to the power 0 is 1, so we get 15,700, add 2,300, we get £18,000. Given that the model predicts the value of the car is decreasing at a rate of £500 per year when t is capital T, part 1, show that 3925e to the minus 0.25 capital T is 500. Okay, so keywords rate. So we're thinking of derivatives. So we need to find dv by dt. So, to differentiate exponentials, you differentiate the power, multiply that by the original function, or the exponential part. So we're going to get minus 0.25 times 15,700 e to the minus 0.25 t. Okay, so that is minus 3,925 e to the minus 0.25 t. Okay, now we know that when t is capital T, the derivative is minus 500. So, we should now say when t is t, we get minus 3925 e to the minus 0.25 capital T. We know that is minus 500. Now, both sides are negative, so divide through by minus 1, and we get 3925 times the exponential is indeed 500. Part 2 then wants us to find the value of t at this instant. So, we are now solving this. So, divide through by 3925. So e to the minus 0.25 t is 500 over 3925. Take logs on both sides, so minus 0.25 t is the log of the fraction multiply through by minus 4, and we get t is minus 4 times the log now that gives us 8.24. Now they want it in years and months to the nearest month. So this is 8¼ years, just about. So it's 8 years, 3 months. The model predicts that the value of the car that approaches but does not fall below £8. C. State the value of A. So, because the exponential has a negative power, as t increases, it gets smaller and smaller and smaller, it tends to 0. So all that will be left is 2,300. So it's never going to get there, because the exponential will never be 0, but it will get incredibly close. So A is £2,300. Okay, then part D wants a limitation of the model. So, the value of the car may not always behave this way. Say, for example, if the car crashes, then its value might straight away be £0. Or, if it's a classic, then its value may start to increase after a certain time. Anything like that. And number 15, given that n is in the naturals, so 1, 2, 3, 4, etc., prove that the n cubed add 2 is not divisible by 8. Okay, so we need to test every natural number. Luckily, we can think of them as two types, odd and even. So, the first thing I'm going to do is say let k be an integer and k be greater than or equal to 0. Okay, so now we can define odd and even ends. So, let's do even first. Okay, so if n is even, we can say that n is 2k. So then n cubed add 2 is going to be 8k cubed add 2. Now that is 2 more than a multiple of 8. So, even ends, or 4 even ends, n cubed add 2 is never divisible by 8. Now let's do odd. So, when n is odd, we can say that n is 2k add 1. So, n cubed add 2 is 2k add 1 cubed add 2. Okay, so we need to expand the bracket, so polynomial expansion again. So, with a small power, I would just use Pascal. So, we want the third row. So, we got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So, we're gonna have one lot of 2k cubed times 1 to the power 0 add 3 lots of 2k squared times 1 to the power 1 add 3 lots of 2k to the power 1 times 1 squared, and then add 1 to the power 3, so 1. And then we've also got plus 2. So, we have got 8k cubed add 3 lots of 4k squared, so 12k squared, add 3 lots of 2k, so 6k, add 3. Now, what do we know? We know that all of this is going to be even. And then we are adding an odd number. So altogether, this whole thing is odd. Therefore, not divisible by 8. So we should then finish by saying that therefore for n in the naturals n cubed add 2 is not divisible by 8. Two non-zero vectors a and b are such that the length of a plus b is the same as the length of a plus the length of b. We want to explain geometrically what this means. So, think about it. If you take one step forward and then one step to the right, that diagonal length from where you started to where you now are is not the same as the sum of the length of the vectors. If you took one step forward and then another step forward, the length of the two steps is the exact same as the length of the two steps added together. So what this means is the vectors must be parallel or in the same direction. And for part 2, two other vectors m and n are such that the length of m is 3, the length of m minus n is 6. The angle between m and n is 30 degrees. Our job is to find the angle between m and m minus n, giving our answer to 1 decimal place. Okay then, so the first thing to do with a question like this would be to sketch. So I've got two vectors m and n, 30 degrees apart. Now we need vector m minus n too. So that would mean we're going along vector m and then negatively along vector n. So I plonk this there, and then stick an arrow there, and then this vector is minus n. Now, vector m minus n is then that vector. Now we know that has a length of 6. Now then, what else do we know? Well, we know that n and minus n are parallel, so because of that, this angle up here is also 30 degrees. So, let's think about what we want. We want the size of this angle here. Let's call it x. At the moment, we can't get x. What we can do is get this guy down here. So we'll call it y. So the way we're going to do that is using the sine rule. So sine y over 3 is the same as sine 30 over 6. Now, multiply by 3 and inverse sine, we get y is 14.5 degrees. So then x is 180 minus 44.5, so we get 135.5 degrees.